Hello everyone, Normal Human Dave here. Today I'm going to be going over something that was requested from some friends of mine off of social media. I was talking about eco-friendly things that we can do as individuals, and just because I think it's super important, the number one thing that, in my opinion, that really makes a big difference in the world is reusing things. A huge amount of energy cost comes from manufacturing things, shipping those things to people, and all the steps in between, going from mining and so on to make new things. Anytime you can get something used or repurpose something you already have, it is one of the biggest effects you can have. Another thing that I mentioned was that I use some alternative energy. Nothing big, a couple solar panels I have that I use to do things like recharge batteries for my tools. I have electric yard tools as well, lawnmower, weed eater, things like that, that I can recharge off of solar panels. And was just happened to be in the middle of moving the system when this topic came up, and I got asked to put together a video showing the setup I have. You can go online if you need to get a system. You can find components typically on a lot of online places where you would normally go to buy used things. If you can't find used, you can purchase new equipment online as well. Typical big online retailers normally have whole kits that you can buy. So anyways, I'm going to go over a couple of the parts and pieces here first. And then I'm going to set up the panels in my new configuration, get everything wired up, and we'll take a look at it actually running in the end. So any kind of photovoltaic system is going to be the same. You're going to have panels. The panels are going to have an inverter. You're going to have cables that carry the charge. And then lastly, you're going to have this at the end of it, an inverter to go from DC to AC. In this case, I have a small little, it's a 400 watt. My solar panels are only 300 watts, so this is actually a little overpowered for the panels I have set up. So if I ever ran this at full capacity, it would actually drain the battery faster than it gets recharged even with full sunlight. So a little overdone here. But it's got some USB connections if you just want to charge phones, and then two standard 120 volt outputs as well to run your standard American appliances up to 400 watts. So to put that in comparison, you can likely run mechanical devices like a blender, but not high energy devices like air conditioners or microwaves. There's no reason you can't take a small system and get an inverter that's going to put out 1,000 watts or 1,200 watts. All that means is you either need a lot of batteries, or it's just going to draw down really quick and burn up what you have. So we'll talk a little bit more about that. The connections we're going to use, so it's going to be panels to battery, and then battery to inverter. The panels are going to be connected with a standard MC4 connectors. This is the standard on virtually every solar panel these days, residential or commercial grade. From the panels, it's going to go over to the battery, and then into this guy here. I've got a multimeter here. I recommend this. You always want to really be careful when you're working with electricity, especially you don't want to cross-wire anything or wire anything backwards. That's how you end up cooking your equipment. Lastly, so these guys here, you'll see there's male and female. These are connectors. I have 3 panels in total. Each one's 100 watts, and together is a 300 watt system. It's 12 volt direct current coming out of the panels. This is for wiring in parallel. And there's 2 ways to wire panels together. You can do parallel, which means the wattage adds up and the voltage stays the same. The other option is you can run them in series, which is where it goes from one panel to the next panel to the next panel. Doing that is going to increase your voltage from one to the other. So for my system, what I have is a basic 12 volt DC system. So the panels put out 12 volt DC. By wiring them parallel, it just adds up that wattage. So I get 300 watts of 12 volt direct current, which is, as most of you probably know, is your voltage on your typical marine or car battery. And the reason I have panels that are 12 volts is specifically so I can run it into basic run-of-the-mill car batteries, and we'll take a look at those. And then from that, draw into this guy, which again is made to draw off of 12 volts and then convert into 120. So again, if you're not an electric guy, you're not the kind of person who wants to sit around and deal with all that, you can buy kits already put together online. Again, I recommend buying used things, but safety first. Buy a kit if you're not comfortable and you just want to get something up and running. They even make all-in-one packages where it's all of this is really one thing with panels that just plug and play, and they open up, they unfold, you get big ones, small ones, different wattages, depending on what you want to do. The battery's built right into it. I'm not a huge fan of those because this guy here, because he has a lot of electronics in him, is only going to last about 5 to 10 years. Warranties typically like 3 to 5 years. You can really get about 10 years out of most electronics if you treat them right. The cabling and the panels are all typically 25 plus years. There's solar panels out there right now that are like 75 years old and still just trucking right away. The idea that it's all built into one housing, all one thing, then the life expectancy becomes whatever the weakest link is. So I prefer having a system where if this guy burns out 5 years from now, then I can turn around and replace him, and the carbon that goes into it, the emissions that go into it are just for him, not for the whole system. And again, because panels are solid state, I mean, it's just glass and silicone. So it's like, why tie those into throwing them out just because some chips burn out? So, all right, so we're gonna go ahead, we're gonna start by getting the panel set up, and then we're gonna start connecting things. Okay, so here's the panels. So each one again is 100 watts, and I just want to go over a couple other components too that I didn't mention earlier. The first one is that we have a fuse. This is again the MC4 connector. This is going to go in line with the power coming out of the charge controller for the panels. The idea there is if these things produce too much for anything to handle, it's a 30 amp fuse, so if we ever have some sort of surge for some reason, it'll protect all the equipment. The other thing is on the back of one of these panels, because they're all going to share this piece of equipment, we have a charge controller. So, and sorry for the noise, it's actually it's getting a little stormy here right now, but so this charge controller is going to control the power coming out of these panels and clean it up before it heads over to the battery, so that the battery is getting nice, clean 12 volt direct current. So we're going to go ahead and wire these up with those parallel wires, and then we'll pick up from there. So here's our panel. This is already wired to go into our controller. So panel number 1. You can see here it's got a waterproof connection, and it's got little clips here that hold, and there's a little tool that you'll need if you want to take these clips off. It just basically goes in there and holds those clips down so you can pull it apart again. So useful little tool. Okay, we've got everything wired up. You can see that we're in the back of the panels here. Everything is zip tied up to the fence just to hold it for right now, kind of a temporary thing. You can see that charge controller is on and registering good charge coming through. So we're drawing power right now to the battery. So let's swing around to the battery and take a look. We're going to just step around. Here's the front of our panels. There's our wires coming out from the panels. Jumps right out of the corner here into the garage. And there is our marine battery, 12 volt DC. And then that from there goes over to our inverter. And I'm not sure if it's going to show up on camera really well. On the inverter screen, let's see if I can get to show up. There we go. It's going to give us the current battery because we have power coming in. It's giving us no particular battery reading because it's kind of infinite power from the panels right now. It's giving us the voltage, 12.5 volts. So that's showing, basically that would say it's fully charged if it wasn't the more voltage coming in. Voltage drop is how this reads how much battery is left. So currently plugged into this, I have a little sander here. And I'll flip the sander on so you can see everything's working and we're drawing power right now. The sander's pretty high wattage. And it's immediately going to jump to probably a low battery warning because the battery is not really that charged and it's currently stormy out, so there's no sunlight. But just to show we got some juice in there, here we go. You can hear that alarm, that's a low battery alarm that's warning us. So, but we could do like more of a trickle charge. Some battery chargers would work well. And we could put those in, and actually that's what I'm going to do right now is I'm going to reconnect all my tool batteries and get them charging up. So there you go, completely free power, and the only carbon cost is in the equipment, which should last a good long time. And here's the standard setup. So we're going from the inverter over to a 210 watt charger for a big lawnmower battery. It's a big 5,000 amp hour battery that we use for the mower. And that battery's at 56 volts, 120 volts going into the charger, and 12 volt direct from the battery and the solar panels. Get to take care of the lawn at zero energy cost.